All right, we continue with our topic, that is car pollution and control. Let's see on how we can control the pollution that is due to car. Let's see the introduction part of the car pollution, and it is control. There are two sources of air pollution. The first source is a stationary source, and the second is a mobile source. With the stationary sources for car pollution, this means that the combustion of fuel for power and heat leads to the stationary source. And the other burning, such as incineration or forest fires, also group up to the stationary sources. Industrial, commercial processes, and solvents and aerosols, they are in a group of stationary sources for car pollution. Let's see for mobile sources. Highway vehicles, cars, which are cars, normal cars, trucks, buses, and motorcycles, they are in a group of or category of mobile sources. Off-highway vehicles such as aircraft, boats, locomotives, farm equipment, RVOs, construction and machinery, they are in a group of mobile sources. So the sources of air pollution. There are some which are natural, some are man-made. So the source, for example, here, this is natural due to volcanic activities. You can see a car here. To its exhaust, there is emission of some gases. This is stationary for a factory. You can see the gases that are emitted here: sulfur dioxide, nitrogen oxide, carbon dioxide, carbon monoxide. These are the primary pollutants. And for secondary pollutants, you can see here, so we want to see the role of car for pollution in our planet Earth. Sources of car pollution. The power to move a motor vehicle comes from burning fuel in an engine. The power to move a vehicle comes from burning of fuel. For any engine to work, it requires fuel and air. If the two tend to burn, they cause the piston to move, which is connected to the crankshaft. The shaft moves. There is arrangement which leads up to the tires, which move upwards. There is a gearbox is placed there for conversion of power. So pollution from vehicles comes from the product of these combustion processes. In addition, volatile organic compounds, VOC, escape through fuel evaporation. So example for this car pollution, here you can see a number of car and their output of smoke being given to the atmosphere. Types of car pollution. There are three main types of emission. Evaporative emission account about 20%. The one that is evaporated because of the heating. So the crankcase emission account about 20% as well. This is the crankcase is where the oil is placed for cooling. Mind you, once it's cooling the engine, it becomes hot, so it tends to give some kind of emission. Exhaust emission count about 60%. This is where the fuel and air burn to cause the cranking of the engine. See here, engine does not want to display here how cranking. I wanted to indicate or to show how air enters the combustion chamber, the place where the burning takes place, where there is fuel and an ignition or spark from the spark plug, that is electricity, to cause the burning, which results to causing pressure of pushing the piston downwards, which the piston is connected. It is connected to the shaft. This crankshaft transfers the power to the gearbox. Gearbox then converts it to, or transfers it to the tires, which causes it to move. But in this engine, there is one inlet that causes the air to enter the combustion chamber, and the exhaust. Now I want to focus on this exhaust, where the burnt gases move out after burning. We call it exhaust. So the exhaust is where we would like to discuss and see how these have impact to our environment. Fuel vapor, that chemicals that enter the air as fuel evaporate, that is 20% of fuel. For example, if you talk about petrol as fuel, if you leave it to the open container, it can expel due to the temperature change. So that is, emission can come up to 20% by evaporation. If we see the vehicle, the motor vehicle as a source of air pollution, as we have said, 20% is evaporative through the carburetor, where the mixing of gas fuel into gaseous form, and the crankcase, where the oil is kept, tend to give the so-called 20% of evaporative of the pollution. But the exhaust is kept after the exhaust. So let's see. So evaporative emissions, hydrocarbons pollutants also escape into the air through the fuel evaporation. With today's efficient exhaust emission control and today's gasoline formulations, evaporative losses can account for a majority of the total hydrocarbons pollution from current mode cars on hot days when ozone levels are highest. So the evaporative emissions, do you know that is gasoline evaporation increases as the temperature rises? I've talked about it, that if you happen to leave a petrol in an open container in the daytime can come up and found nothing in it, because all of it can get evaporation. So running losses, the hot engine and exhaust system can vaporize gasoline when the car is running. So there is a dyno and running losses. A hot shock, the engine remains hot for a period of time after the car is turned off, and the gasoline evaporation continues when the car is parked. Mind you, this fuel requires a certain temperature to remain at its state. But if the temperature rises, it tends to evaporate. There's a hot shock. So it can evaporate even when the car is not running. It has been packed. Only that because there's a change in temperature. Fueling, gasoline vapors are always present in the fuel tanks. These vapors are forced out when the tank is filled with liquid fuel. So they also contribute to the car pollution. See here, refueling losses displaced vapors. Evaporative emission, dyno, running losses, hot shock. So you can see how the two are grouped, refueling losses and evaporative emission. Let's now see for the exhaust emission. So our major focus dwells. The combustion process. The gasoline and diesel, gasoline for petrol, diesel fuel are mixtures of hydrocarbons, compounds which contain hydrogen and carbon atoms, the two hydrogen and hydrogen and carbon atoms. In a perfect engine, oxygen in the air would convert all hydrogen in the fuel to water and all the carbon in the fuel to carbon dioxide. Nitrogen in the air would remain unaffected. If the engine would be perfect, and make sure that oxygen in the air is all converted. Oxygen in the air ensures the hydrogen in the fuel is converted to water, and all the carbon in the fuel is converted to carbon dioxide. Then nitrogen, which is in the air, would have been not affected at all. Prior to that, in reality, the combustion process cannot be perfect. And automotive engines emit several types of pollutants. Because it cannot be perfect engine by 100%, so some tend to give us some pollutants. If it would have been perfect, it could not give us the hydrocarbons. So the typical engine combustion, that is fuel plus air, you get hydrocarbons, and hydrogen oxide plus carbon dioxide plus carbon monoxide plus water. In reality, or in normal circumstances. Let's now indicate clearly this thing. So exhaust emission. There are 4 basic types of exhaust emissions. In that exhaust, there is emission of hydrocarbons, HC, carbon monoxide, CO, and oxides of nitrogen, NOx, and particulates. Gases are released from the tailpipe while a vehicle is operating. Exhaust emissions. So this is a vehicle showing how emissions are being produced. So you can see at the exhaust there is a lot of pollutants, carbon monoxide, hydrocarbons, nitrogen oxide, and smoke, PM. Yeah. Exhaust emissions occur during two modes. There are two modes for emission that can be noted. During cold starting and driving a vehicle, the first few minutes result in higher emissions because the emissions control equipment has not yet reached its optimal operating temperature. So at the initial stages, a lot of smoke will be noted for exhaust system because the control equipment for starting has not reached its operating temperature. So it requires heating it up. Running exhaust emissions, when the vehicle, the car is running, pollutants are emitted from the vehicle's tailpipe during the driving and the idling after the vehicle is warmed up. So hydrocarbons, HCl, the others behind. Carbon monoxide, that is CO, extreme toxic emission resulting from the release of partially burned fuel. So if you talk about carbon monoxide, it's incomplete burning where has taken place. So it's very dangerous for human consumption. CO prevents human blood, carbon monoxide prevents human blood cells from carrying oxygen to the body tissues. Symptoms are headache, nausea, can lead to vomiting, blood, vision, and fatigue. Basically, stoichiometric quantity of the oxidizer is required. This is that amount needed to completely burn a quantity of fuel. For carbon monoxide, if more than stoichiometric quantity of oxidizer is used, the mixture is said to be lean. That means the mixture is not rich enough to ensure a complete burning of the mixture. If more fuel is supplied, the mixture is referred to as rich. A rich air fuel would increase carbon monoxide. Lean air fuel mixture would lower carbon emissions. Oxide of nitrogen. So here the oxide for nitrogen produced extremely high temperature during combustion. Air consists of about 79% in nitrogen and 21% of oxygen. When enough heat above 2500, nitrogen and oxygen in the fuel mixture combine form nitrogen oxide emission. An engine with a high compression ratio, lean air-fuel mixture, and a high temperature generated will produce high combustion heat, resulting in formation of nitrogen oxide. Compression ratio is very important parameter for measuring engine performance. The compression ratio may be defined as the ratio of the maximum cylinder volume when the piston is at its utmost position, BDC, to the minimum cylinder volume, the clearance volume, with the piston at its innermost position, top dead center, that is the sum of the swept and the clearance volume divided by the clearance volume. Yeah, it's a ratio of this volume. The volume when the piston moves and leaves a space above where that volume is equated to identify the amount of air present during the burning, or the air that has been compressed, which will enable it to function after burning. How much space is left when the piston has gone up to its top center. Oxide of nitrogen. Petrol engine have a compression ratio of about 7:1 or 10:1. But to produce self-ignition of the charge, diesel engine usually double these figures and may have values of between 14 to 24. Exposure to high level of nitrogen or nitrogen dioxide may lead to lung. Exposure to high level of nitrogen dioxide may lead to lung damage and respiratory diseases. Particulate matter. Particulate matter, PM, pollute consists of solids and liquids, droplets, up to 10 micrometers in the diameter suspended in the air. Large dark PM may include smoke and soot from incomplete combustion. Through PM may also include dust. These cause particles along with the smaller ones are known as PM10. Found this for air pollution. PM measures less than 2.5 micrometers in diameter and can include particles so small that they may only be seen using an electron microscope. These are known as PM2.5. Diesel vehicles are a major source of both coarse and fine PM pollution. See? Health effect, fine particles. Long-term exposure is linked to lung cancer, heart diseases, lung diseases, asthma attacks, and other health problems. So ways of reducing car pollution. This comes to be very important here to note. You have to drive less. In order to ensure reduction of car pollution in our environment, we need to drive less. Keep cars well maintained and tires properly inflated. Turn off the engine when your vehicle is not in motion. And purchase low-emitting and fuel-efficient vehicles. Share a ride, take a public transportation bike or walk. Refuel your car after 6 ATM. Let's talk about fuel. Fuel quality, low at low sulfur, biodiesels, adductive conditioners, and storage should be kept in mind when you're dealing with the fuels. So maintenance case. Adequate maintenance is essential to limiting diesel particulate emission. Scheduling of maintenance is very important to ensure no car pollution. Typical emission control device. Positive crankcase ventilation. Positive crankcase ventilation valve. How to control these emissions that are emitted through the exhaust system? So there is a positive crankcase ventilation, PCV. Evaporative emission canister should be employed. The storage system consists of a canister containing activated charcoal located in the engine compartment. Activated charcoal has an affinity for hydrocarbons, and on a recycle base can store 30 to 35 grams of the fuel per 100 grams of charcoal without breaking through. Typically, 700 to 800 grams of the charcoal are used in a vehicle system. Exhaust gas recirculation, EGR, valve recycling of a portion of exhaust gas to inlet charge increases dilution. This reduces the peak combustion temperature, since the inlet exhaust gas being recirculated will act as a heat sink. This also reduces the oxygen availability. About 15% recycle will reduce nitrogen oxide emission by about 80%. The maximum percentage which can be recycled is limited by rough engine operation and loss of power. So vehicle emission control, this device is termed catalytic converter. Some term it is engine muffler. This is kept between the engine and the engine output, where there is exhaust pipe leading the smoke or emission of the gases. They burnt out the gases. But these gases, before coming out, they have to pass through this device. Oxidized, mind you, in that fuel oxidizes the remaining hydrocarbons and carbon monoxide emissions that pass into the exhaust system. This device is very paramount. It ensures the completion burning of the hydrocarbons and the carbon monoxide before they are given to the exhaust system to come out of the vehicle. Extreme heat ignites these emissions and change them into carbon dioxide. See how the temperature has risen up to 760 degrees centigrade. So catalyst is then from the word catalytic converter. Is catalyst is being a substance that speeds a chemical reaction without itself being changed, coated with ceramic honeycomb. So catalytic substance such as platinum and palladium treats hydrocarbons and the carbon monoxide emissions. Rhodium acts on the nitrogen oxide emissions. So let's see here if we can manage to see this. Good. So catalytic converter here, it is construction. Tailpipe emission. So you can see at the tailpipe there is water, carbon dioxide, nitrogen, leaving this converter goes to the pipe outside. So if it is effective, the output will be not harmful. However, if we do not have this, the output would have been exhaust gas, raw emission, that is hydrocarbons, carbon monoxide, nitrogen oxide. So in the absence of this, we would have come out with these which are pollutants. So this ensures more burning of the carbon monoxide to carbon dioxide, more burning of hydrocarbons to split into hydrogen and water, to split the nitrogen oxide into carbon dioxide and nitrogen. So that is the importance of having the catalytic converter for reduction of car pollution. So here I would like to know the different types of converters. Vehicle emission control system types of converters. Mean catalytic and a two-way catalytic converter. However, principally they are working on the same principle to ensure more burning of the pollutants before coming out of the exhaust system. Catalytic converter normally has both a three-way reduction and a two-way oxidation. It means you can reduce or you can oxidize. In the mixing chamber is provided between the two. Air is forced into the mixing chamber to help burn the hydrocarbons and carbon monoxide emissions. So this is the engine. As we saw at the beginning, that there is a carburetor where the emission due to evaporative can be noted. And crankcase down there. But there is an electronic control unit for evaporation. But here is our catalytic converter, a three-way catalytic converter that ensures more burning of the emission from the engine after burning before going out. Mind you, this also has impact to the generation of power. If the vehicle does not have this device, there will be reduction of power. So it's very important to have this. If at all you go for service, make sure the muffler is working properly, as it ensures the effectiveness of the power generated to go into usefulness. Thank you. That makes it the end for car pollution.